Assalamualaikum and salam sejahtera. We are from Group 21 and today our group will explain about corrosion of matter. First, what is corrosion? Corrosion is slow damage or deterioration of matter caused by chemical or electrochemical reaction with the surrounding, such as water, oxygen, acid, or salts. It is important to study corrosion because it leads to major economic loss. Machine structures and pipelines need frequent repair or replacement. Corrosion can also cause serious safety risks, for example, when bridge, vehicle, or industrial equipment fail. Besides that, corrosion also affects the environment, especially when leaking pipeline release oil gas or chemical into soil and water. Corrosion actually works like a small electrochemical cell on the metal surface. At the anode, ion undergo oxidation forming Fe2 plus ion and release electrons. These electrons flow to another part of the metal surface, the cathode, where oxygen is reduced in the presence of water. The Fe2 plus ion produced then react with oxygen to form brights, which the brown flaky substance we usually see on the crop ion. In summary, corrosion involves oxidation at anode, reduction at cathode, and represent of an electrolyte like water, which completes the electrochemical process.
Good day, everyone. So today I'll be presenting on the fundamental electrochemical principle that involve in corrosion. Corrosion is not simply the rusting of metal, it is actually an electrochemical process that involves electron transfer reaction. So whenever a metal corrodes, its surface separates into two distinct regions, which is anodic and cathodic areas. Electron flow between this region and ions move through the surrounding environment, such as water. So this combination of oxidation and reduction reaction is what drives the corrosion process. Okay, as for the corrosion as an electrochemical cell, so corrosion can be understood as a type of electrochemical cells that occur naturally on a metal surface. So even on a single piece of metal, different areas will behave differently due to its surface imperfections, or maybe it has any impurities or oxygen differences. The anodic region, the metal will undergo oxidation and release electron, while in the cathodic region, a reduction will take place where a species in the environment like oxygen or hydrogen ion will accept those electrons. So these two half reaction will happen simultaneously to form a complete electrochemical cell that continuously drive corrosions. So let's break down the reaction happening at each site. So at the anode, the fundamental reaction is oxidation. So metal atom will lose its electron and dissolve it into solution as metal ion. While at the cathode, the electron will release from the anode must be consumed. In neutral or passive environment, oxygen is typically reduced to hydroxide ion. In acidic environment, hydrogen ion will gain electron to form hydrogen gas. So these two half reaction work together and sustain the process. Okay, now electron and ion flow. So corrosion cannot happen without the movement of electron and ion. So electron flow through the metal itself from the anodic area to the cathodic area, and at the same time, ion move through the electrolyte such as water or moisture in the air. Metal ion that form at the anode migrate away into the electrolyte, while anions such as hydroxide or chloride will balance the charge. So this movement is essential because corrosion requires both electron and ionic pathway. So if either path is blocked, corrosion will slow down or stop. Electric potential. So electric potential help us predict which metals are more likely to corrode. Every metal has its standard electric potential, or we mostly known as inert value. So as we know, metals with more negative inert values will oxidize easily. So when it oxidizes easily, corrode will happen more readily, while metals with more positive inert values are more stable and less likely to corrode. So when two different metals are in electrical contract, the one with the more negative potential becomes the anode and will corrode faster. So this is what we call as galvanic corrosion, and we can commonly see it in pipelines or construction structures. And for the last is the Nernst equations. So this equation will allow us to calculate the actual